we have all in small numbers only, not much of a difference. Even if it's scale also not, it is not going to make a big difference because we don't have any large numbers, right? So we will do dummy encoding of object calls, or before that, let us look at our date columns. We have green taxi df dot, green taxi dot lpep drop of date time dot head. Now in taxis, or let us say retail sales data, will time has an effect? In taxi service, generally in taxi service, there will be rush hours, like in the morning there might be demand, afternoon demand, or evening demand. So we have this drop of date time, pickup and drop off times are there. Pickup time and drop off. You can extract variables from date time. We can extract date time, weekday, whether it is Sunday, Monday, Tuesday, we can extract. We can also extract the hour. And there are other things also which you can extract, like is month end, is month beginning, is quarter end, quarter beginning, like this. We can extract variables from if your date is in date time format. Now, in this case, our date is in date time format, right? Our date is in date time format. So we can extract these, data points. So this is 1 month data. I think year and month we can ignore. Yeah, it is 1 month data. So we can ignore year, month, and quarter. But we can extract weekday and hour. New variables. We will extract new variables called weekday. Whether it is Sunday, Monday, Tuesday, we can extract. There is an inbuilt library in Pandas. Earlier it was a different library. Now it is integrated into Pandas called datetime. Short form is DT. So datetime library, earlier it was a separate library in Pandas Python. Now it has been integrated into Pandas. Now using this library, we can extract the required parameters or required variables. I'm adding it to object calls because we will have to anyway dummy encode them. Object calls, square bracket, green taxi dot lpep drop of date time dot dt dot, let's see, object calls, weekday. Oh, 111 we got. If I say, so the first day is what? The first day of the week is 1st November 2022. It has given it as 1. So Tuesday. It is Tuesday. 1st November 2022 is Tuesday. That means 0 is Monday, 2 is Wednesday, 3 is Thursday. So you can see the weekday counts. So we are generating variable called weekday from date. Generating a variable called weekday, whether it is Sunday, Monday, because weekdays also we have a demand, right? How many trips go on weekdays? You can see here. Tuesday, there are 11,529 trips. Maximum trips are on Friday, followed by Thursday. Then Saturday, Sunday, we have lowest number of trips. Lowest number of trips are on Wednesday, followed by Tuesday. Most trips. Counts, no? We are counting how many times Wednesday is coming. So Wednesday is coming more times. That means more number of trips happened on middle of the week, Wednesday, followed by Tuesday. So we are using the date time to extract weekday. Okay, all of you done this? Now we'll extract hour. Object calls, square bracket, single quote, hour is equal to green taxi dot lpep drop of date time dot dt dot object calls dot hour of the day dot value counts dot plot kind is equal to bar for I in AX underscore containers, huh? Or AX dot containers. Square bracket 0, right? AX dot bar underscore label I comma font LT dot figure fixed size is equal to 30 comma 15. So too much of this thing. 20 comma 10. Font size we will increase. Huh? Yeah, font size 12. Now, during whichever most of the trips are happening, 5 p.m., 6 p.m., 4 p.m. So between 3 p.m. to 5 p.m. there are many trips, followed by 7, during which hours you are getting most trips. This is called time analysis or time intelligence. Average total amount of weekday and average total amount of hour. Create a bar plot of average total amount of weekday. Now we found out Wednesday is peak demand. Yeah. But are we getting more total amount on Wednesday? Generally, if there are more trips on Wednesday, you should get more fair amount, right? Total amount. So just check average total amount weekday wise, average total amount hour wise.
We'll know what is the charge.
We'll know the actual revenue and how the thing. So after doing this, group by with total amount and weekday, total amount and hour, the new variables which I have created. So here we are creating two new variables, weekday and hour. Hour is 24 hours format. If you can see, hour is 24 hours format, 0 to 23. Weekday is 0 is Monday, 0 to 6. 0 is Monday, 6 is Sunday. Monday to Sunday format. So amounts are okay. Actually, you can try, na? Let me try. Civics object has no container, sir. I think I didn't get the output answer. You got the output, right? Then why it is not coming? Actually, I didn't plot. Dot plot kind is equal to bar. That is PLT bar, na? Pandas bar is always safest. You'll get X labels and Y labels and all, na? So we are getting amounts almost equal, except for weekday 3, we are getting higher average amount, and weekday Saturday and Thursday, Monday, Tuesday, Wednesday, okay. Thursday and Saturday and Sunday. Thursday, Saturday and Sunday, we are getting higher amounts. You can add labels here also, right? Labels command will it take? W, T, H, S, A. Oh, it overwritten the other labels. This labels command has to be some other, is not taking labels from here also. So set underscore X label. AX dot set underscore X label, not X label then. X ticks, huh? You can create a dictionary and give also. Set X ticks labels. Set underscore X ticks labels. Oh shit. T W T H. Yeah, for Y it is Y tick labels. See, horizontal axis. Set underscore X ticks labels. X label will give the label to X axis. Tick labels will give you the ticks.
We don't need to use find
Directly only, yeah?
directly we can do.
Okay.
That bar, in that bar, parameters we can take color and all.
Yeah. Green and color orange font. Do the same plot for our average total amount by hour. You want to reduce this date labels are you talking about?
Yeah.
Bar label, right? Here I, you can make it as np dot round of I, comma 2. Okay. Okay. Now we can't add it here. We have to add it here only. np dot round, open bracket, till mean, comma 2. Got it?
Right.
Add it to the top. We'll extend the plot window. PLT dot figure is equal to 20, 10. Font size is equal to 12. Color is equal to. So early morning 5 o'clock, most of the average amount is high, 29. During the day, 12 o'clock mid is 19.58 higher. So you can extract, if your date is in format, you can extract weekday, year, month, hours, weekday, all those things you can extract. Okay, time variables. After that, you can delete the time variables. After extracting information, you can delete the time variables. Now, look at our date format. Green taxi dot lpep drop off date time dot. If I add as type int, what will happen? Let me check. So if I convert the date, you get it in a number format, Unix number format, integer format, or number format. Date into number format, it is coming, right? See, our original date time is, this is our original date time. I am converting it into integer format, so it will convert it into as type int. See, it is converting into number format. Now, if I divide it by 10 to the power of 6, we'll get the actual date sort of a thing. We'll get this date sort of a thing, right? Then we can convert it into what are you getting?
You know, as the date time, like from date time to int.
No need of inputting. Int 64 you have to do. Int 64 divided by 10 to the power of 6. So I'm just showing the format changes, how it I'll implement it. Then we have this pd.to_date time. The function to convert any date to date format is PD dot 2 underscore date time. Pandas.
Why are we using the table?
To remove the zeros. When you convert it, you get a lot of zeros, right? To remove those zeros, to get the actual number. So PD dot 2 underscore date time will convert the date to the date format. Date can be in float, string, or any other format. There are a lot of methods. We are interested in units. Yes, MS, US, and NS. So unit is equal to, shall we say, seconds, or unit is equal to D? Or time delta is there. M is for minutes. Okay, we want units is equal to seconds so that we can get the time with seconds. PD dot date time 2 underscore date time. So it is going to 1970. But we are bothered about difference in time, na? We are not bothered about the actual date. Or we can do direct, I think. Time delta is there, na? Let us do one thing. Instead of doing this, we will take duration. Trip duration is equal to green taxi dot LPEP drop off date time minus green taxi dot LPEP trip duration dot head. 0 days, and we got the 3 minutes 19. Each trip duration we got it, right? Now, trip duration is equal to PD dot 2 underscore time delta num calls dot trip duration. Num calls dot trip duration dot head. Actually, we want the time only, right? But we don't want all the others. Can we do describe? Okay, we got time, this thing, median 12 minutes.
No, but we can use this BT function.
What function?
That thing besides the BT daytime.
Acha, you are saying date time, we want to, DT dot minutes is there. DT dot minute is there. Instead of doing this, we can do trip duration dot DT dot, it is there, DT dot minute.
Here it's not showing, but this tab is. We have seconds, total seconds, nanoseconds, microseconds, for days.
Total seconds you can take then. No, it didn't come. It says bound method. Method is not correct. So what is this format? Extract minutes from time delta 64 ms from time delta Python. Everything is answered on Stack Overflow.
Sir, what is the data type of tribulation?
Tell time delta, na?
Doing M8 NX, D type.
D type is time delta 64, no? It is coming here. M8 nanoseconds. D type is time delta.
Drop off time, like, are these both in single format?
Yeah, there, see, we got it in minutes. We have got it in minutes. We have 3 minutes, 19 seconds, 21 minutes, 48 seconds. We have to convert it into, convert times, we got now to the right place. DT dot total underscore seconds. Or you can divide it by NP dot time delta 64 1 comma S or dot as type. We'll use this one. This is the best option. So this is the data we have. We have to convert it into seconds.
With 80 seconds, we are getting seconds. We can divide that by 16, then we can get actually.
No, we want in seconds only, no? Minute and seconds. We got it earlier.
No, we use total seconds. Now, if you use seconds, then we are getting that. Do that, sir, once. DT dot seconds.
DT dot seconds, huh?
Yes.
Dot DT dot. But for me, it is giving error.
I created another variable only.
Minus only, right?
Minus. Here, instead of trip duration equal to trip distance. Where is trip distance, sir?
Yes, we got it in seconds. Duration in seconds. Trip duration in seconds. So this is another variable we are creating. How many seconds the trip happened? You can, if you want to convert it to minutes, divide it by 60. 3.31 minutes, 21. Okay, you can divide it by 60 so that you can have a good value. Drop off time minus pickup time. Now using trip duration, can you find out peak traffic time? How will you find out peak traffic time? During which hour of the day we have peak traffic? If you take average trip duration, whichever is higher, that time you have the peak traffic. More traffic will be there, right? So group by hour end, so we can know during which hour of the day the traffic is high. Because if trip duration is high, traffic is also, if you are traveling more amount of time, that means traffic is, so hour-wise trip duration do it. create a bar plot of hour-wise trip duration. Why it is not correct?
Really, how can I say?
You know, New York City has a lot of pubs and all those things, right? The city never sleeps. So 47 minutes in the midnight, 6 o'clock, 35 minutes, 4 o'clock, 23 minutes. So it's okay, it's correct only. You didn't divide it by 60. You didn't convert it, it's in seconds only, na? You divide it by 60 to convert it into minutes. You are having seconds only. Object calls dummy is equal to ad dot get underscore dummies. See here, we have to dummy encode the object calls. See, it is in text and some of it is categoricals, right? This is the actual data format. You have to dummy encode build model. So we got 41 variables or 41 columns. Once you convert the dummy encoding of object calls, combining both the data frames to one dummy data frame and num calls data frame, splitting the data into dependent and independent variables, and then doing the train test split. Train data 70%, 30% test data. Random sampling. X train, X test, Y train, Y test, train test split, X comma Y. Test size is 30%. Random state is 42. Randomly sample. So now you have train and test data both. You're getting error, huh?
Yeah.
1 second. Yes, let me check if the data is working or not. Underscore model, import linear regression. That model is equal to linear regression dot fit x underscore train, comma y underscore x underscore train, comma y underscore. Oh, 99.94. We have multicollinear issue. Yeah, we have multicollinear issue. We did not check multicollinearity. We have multicollinearity issue. Import cborn as SNS dot heatmap dot CORR, comma not is equal to dot figure size equal to check multicollinearity is there. That's why we got a total amount and total amount and fair amount. Total amount and fair amount, we have a multicollinearity issue. You have to drop fair amount.
You can drop it from X direction.
That is problem with the updation. Update your library once. Updated it, huh? Then why it is converted data dot seconds duration. Mine is also float. See, retype is float only for me also. I'm getting it group by for float. It should work, right? Copy the error into what you call Chrome and check. After dropping fair amount, you got the output correctly. See, after correcting multicollinearity, how drastically R square changed. I think we have a problem with Y. What is this? Y dot plot. Achha, kind is equal to box. See, completely skewed to the left. Our Y is completely skewed. SNS dot NP dot log 1T of Y. So if you do logarithmic transformation, it is moving to center. Infinity, nan, or value too large. So log is not working. Despite trying my level best, it is not taking. So we have to do decision tree regression. All right, where do you want to go? Regression model building. There is concatenation. You have to combine num calls and object. Syntax is here. You have to add a cell here. You have to combine num calls and object calls dummy. Object calls dummy of num calls and object calls dummy of done. The fair amount will drop here. Fair amount drop here. Fair amount will drop here. తర్వాత సెల్ యాడ్ చేసి అది మీకు లైవ్ కంట్రోల్ సరిపోతుంది అది చేంజ్ చేయదు సింగిల్ ప్రొసెస్ యాడ్ చేయండి చేసుకొని అప్పుడు ఎక్స్ట్రీమ్ డ్రాప్ చేయండి అది వర్క్ పెట్టి ఫేర్ అమౌంట్ డ్రాప్ చేయండి ఫేర్ అండర్స్కోర్ అమౌంట్
So then 70% will be training model, 30%.
Yeah, that is test.
And whatever the random will picking the data.
Random rows will pick. Or fitting. అదే కదా అందుకని ఫేర్ అమౌంట్ డ్రాప్ చేయాలి ఫేర్ అమౌంట్ డ్రాప్ చేసి ఉంటుంది మీరు see total amount you might have dropped after X you have to drop fair amount also then you should not get 1 you should get 0.270 actually we have total amounts equal to 0 that is why logarithmic transformation is not working total amounts there are equal to 0.
Then how will we train the models?
We can't use linear regression because R square is very less. R square is very bad here. So this is failing 0.270. Okay. So what is happening is, because we have zeros, we are not able to do logarithmic transformation because log 0 will be infinity or none. That is the problem we are getting. Hey, anybody ran decision tree? It gave you good performance or that is also bad? Hey, you corrected it, Gayatri? 0.27 you didn't get. Check the previous columns. You might have double dropped it. See, overfitting, decision tree. 9, right? Cross validation you have been referred. See how drastically it is changing. R squares of the other models. See? Hey, it's 4 o'clock. You can take your break. More on excellent, right? Also, you dropped it from not second X. Combined here from so y and x ఇక్కడ x పేరు ఇక్కడ ఇవ్వాలి కదా ఏ పేరు ఇచ్చారు అదే వాడండి
మేము అయిపోలేదు మేము చేసుకోవాలి ఇది చేయండి దీని తర్వాత ఒక నిమిషం ఆగు నెక్స్ట్ కాదు బాక్స్ ముందు ఏం లేదు ఇంకా చూసుకోండి బాక్స్ ముందు ఇది ఉంది YXY ఉన్నాయి ఇంకా కిందికా ఇది చేసావు సీబన్ దీని తర్వాత ఓకే ఇంకా నేను చేసిన అదొక్కటి చెప్పండి మరి అది డివైడెడ్ బై 60 డివైడ్ బై 60 పెట్ట అక్కడ ఇక ఇదే కదా నమ్కోస్ డాట్ ట్రిప్ డ్యూరేషన్ అదే కదా ఇక్కడ ఉండే కదా అది పెట్టేదా బయటతో వర్తిస్తావా
చెప్పిందే చెప్తానని ఎప్పటికీ ప్రతిసారి ప్రతిరోజు చేసినాయే మన దగ్గర పక్కన చేసింది ఈరోజు ఎక్స్ప్లెయిన్ డైలీ ఏంటంటే యాక్స్ యాక్స్ వై పెట్టేసి అది వచ్చింది సార్ ఎక్స్ప్లెయిన్ వై పెట్టండి నెక్స్ట్ వై
స్పెషల్ కౌన్సిలర్ అదే కౌన్సిలర్ ఆమె కౌన్సిలర్ స్పెషల్ బెనిఫిట్స్ ఇచ్చారు కదా నువ్వని అది ఎవరికైనా అంతే ఎవరికైనా అంతే అప్డేట్ ఉంటుంది కదా సీట్స్ ఇస్తారేమో
Yeah, you got this? All right, I like to run decision tree, random forest.
Can you go from starting?
You want,
From reading,
see, logarithmic transform, this is again complex question. All of you can see the font size. When do we use logarithmic transformation? When data has positive skewness. You suspect an exponential component in the data. Exponential component means larger values. Generally, exponential means e to the power of, right? E plus e minus you get, na? When you have larger values, you do logarithmic transformation. Data might be best classified by orders of magnitude. That means you can apply what you call ordinal data is better, not the categorical data. Now, this is very important. The transformation cannot be performed on non-positive. Negative value log and log 0 will be infinity or none. You getting it right? Why logarithmic transformation is failing in our case is some total amounts are 0. If you look at our total amounts, there are some of them which are 0. Log of 0 will be what? Infinity, right? That is the problem here. This transformation on non-positive data or 0 data. Now, after this, I tried square root transformation. Generally, this works with zeros and extremely small values. Square root works with 0 cents, extremely small values. But still, for our data, somehow it didn't work. This also, when I do square root transformation, it gave me infinity error and larger value error it gave. Again, this transformation cannot be performed on negative data. Got it? Logarithmic transformation, square root is failing in our case. Why? Because we have zeros and negative values. Then we have reciprocal transformation. Now, reciprocal transformation is to be used on ratios. If your dependent variable is ratio, loan to income ratio, you derived some value by using division. Ratios are generally derived from, right? So when your values are derived using division, then you will use reciprocal transformation. The three transformations which are used for positive skewness. In our case, logarithmic transformation did not work and square root transformation also did not work. I tried both of them. Now we have an option here. We can keep zeros as it is and remaining values we can change to logarithmic transformation if you want to use linear regression. But what we found, decision tree and random forest would be better options. Now see, random forest, it runs RF model dot score X train and Y train. See, 93.65. So instead of struggling with linear regression, we move to non-parametric algorithms. Remember this very important thing. Non-parametric algorithms, decision tree, random forest, and gradient boosting are non-parametric. What is a non-parametric algorithm? No assumptions. Parametric algorithm will have assumption, like multiple linear regression. What is the primary assumption? Data must be closer to is our Y train closer to normal distribution? No. That is where linear regression is failing. Now, decision tree and random forest are not bothered about that. They are not bothered about skewness. You give any type of data, they will work. But in our case, decision tree is overfitting. Now, let us check whether random forest also overfits. That's what we are checking. It doesn't overfit. Now, now, when will you use exponential transformation?
When the skewness is
Negative. Power transformation, when variables are area, length like that, you use power transformation. Arc sign transformation, when the data is in proportions and percentages. Arc sign transformation, when your data is in percentages and proportions. Okay, I will send you this link. This is one of the common interview questions. What are the methods to correct positive skewness and what are the methods to correct independent variable? Yes, I have sent it. Now it's clear, right? But when your basic algorithm performs badly, even if you do transformation, 0.27 will not become 0.9. 0.27 will not become 0.8 or 0.9. It will be 0.5 or 0.6. That only it will do. It will not drastically. So better to move to other algorithms. If your base algorithm is not working, go to advanced, which is tree-based models first. After tree-based models, we have other algorithms which we will be discussing. Tomorrow we don't have class, right?
tomorrow we do.
Tomorrow we have, yeah.
Is there any better algorithm than random forest?
Yes, see, every algorithm has its own utility.
What is the, other than computing problem, what is the negative of random forest?
Computing itself is costly, right? But sometimes you have to use it. See, there is no good algorithm or bad algorithm. It depends on your data type. What type of data you are dealing with. Some data prefer tree-based models and ensemble methods. Some data you have to go with linear regression and logistic regression based models only. It depends on the data you deal with. We can't say that this data works with this type of algorithm and all. That broadly we say, but it is not. So until unless you build models and run them and test them, you can't say what is going to happen.
Only based on the R-square score line, then only we can decide that.
Yes. Based on the R square, accuracy, RMSE, and other metrics only you will decide. And higher things is not always we want. That means we always don't target 90%. No. We are satisfied if it is around 80% also. Subjectively, it is predicting to a good, better extent. 80% is also good. Because sometimes what happens in real-time data science is when we are targeting higher accuracies and higher R square, we lose the model significance. The model starts performing badly. So we go with 70% or 80% like that, and then we accept it and go. So this is real-time data, right? We can't do anything with this data, right? This is actual data generated by taxes. We can't manipulate it. What we are doing is we are trying to adjust it to a certain extent. Can we manipulate it completely and fit it to linear regression? We can't.
No sense in it.
We can't do that. There is no sense also, right? So we have to go with the data. So this data, taxi data, base models is not working. So we are using ensemble models or ensemble methods. Okay. So that's what. There are some problems you will solve with linear regression also. Not that linear regression is outdated. There are some problems in business. Even today, people use linear regression. Some problems require neural networks, even more powerful and more computing, more costly than random forest.
The neural networks come under real.
Yeah, deep learning, artificial intelligence, deep learning and all.
It is the complex.
Initially, a combination of algorithms were used in DL initially, but once neural networks became easy to be computed on CPUs, now everything moved to neural networks. Earlier, deep learning in AI means combination of models will be used. Random forest with decision, what we call linear regression, random forest with k nearest neighbors, like that combination of algorithms were used. Now, instead of doing that, they are using neural networks directly. Initially, neural networks cannot be run on CPUs. They required separate chips and separate architecture. But in the last 5 years, they designed them such a way, they remodeled the equations in such a manner that now you can run it on a 4 GB RAM also. Now neural networks, base neural networks can be run on 4 GB RAM also.
So what is the scope of DL in our?
DL you will not be working. DL, see, DL is highly specialized. Initial days of career you will not work on it. For DL, you need to have mathematical background.
Even in
You generally, without mathematical background, understanding deep learning will be difficult. Particularly calculus, derivatives, calculus and all has to be known. Mathematics is background for deep learning. Second thing, deep learning involves little bit of what you call, not little bit of, more of advanced mathematics. BTech, beyond BTech, you have to go beyond BTech. It has to be PhDs and doctorates that do. See, if you are working on agriculture data, you know, right? Nowadays, a lot of work is being done on agricultural data. Now, I have a student in PJ23 weekend batch. He works in a company where they are analyzing. They work on pesticides and this chemicals for agriculture. They get drone images of crop growth. In a 1 acre crop, all the crop growth will not be same, right? Some parts, the trees will be higher, the plants will be higher, somewhere it will be lower. So in an acre plot, depending on the fertility of the plot, somewhere the plants will be very thick and very high, somewhere it will be less and low, like that it will be there. So using these drone images, they want to capture the least growth and high growth parts of the plot. And then not in the current, if they can do addition of fertilizers, they can do, or for the next crop, that side of the land where there is less growth, they want to put more fertilizer and make it equivalent to this. So that has to be done using images. So they are using drone images. They have developed a database of drone images of agriculture growths with different light indications and all. Now they are building algorithm that detects the less growth areas and high growth. Now in an image, you cannot see visually.
Yes.
But algorithms can see that difference in the image based on the pixels and all those things. So for doing that sort of work, if you are interested, you need to study the algorithms and mathematics. So we don't use machine learning algorithms there. There we have to use computer vision and those vision algorithms. Deep Boltzmann machines, DBZs we call them. Boltzmann machines are there. They're very highly mathematical and computing intensive algorithms. So those things have to be used. So you might have to study computer vision, image analysis, satellite image analysis or image analysis, separate algorithms are there. Those things you have to study. You want to study them, you can study them. You have to invest time based on once you complete it, you will be easily studying them on your own. You don't need anything else. Using some YouTube videos and some basic things, you can run those models on your systems. If you can do it, you will get higher salaries. They are one of the highest paid jobs. You have to put the money. So that fellow whom I constantly shown us, Sai Charan, he was the guy who joined that Happy Monk with very less salary. See, he worked on this thing, approaches for face re-identification. He spent almost 3 months on this face re-identification. He was very weak here. He didn't understand what is image analysis and all. He studied that whole thing and he did it. Now he is working at 9 lakhs package, 8.8 or something like that. Face re-identification. He is not a BTech guy. Still he had done. See, he has studied this one. VGG is a 16-layer network. It's a neural network. So this is a presentation he made for the client. Cars. He has worked on traffic signals. See, skewness and cutoffs is very important in images. So normalizing feature vectors, cosine similarity. So he worked on it. He's not a BTech guy.
I heard that like we need to publish some research.
Yes,
in order to get it.
you can. If you are interested, you can do research paper publishing also.
I don't exactly know what.
That's the problem, now. So what we are trying to do is, you can write initially articles. If you want, like in PJ 17, one person has submitted article to Analytics Vidya. Whatever we are working now. So like take, for example, New York data. We have worked with date variables, how we converted hours. You write a simple article, 500 words article. That I have used this methodology to convert date time, convert it into this methodology, and then we implemented it and we got this course. You write this simple article and submit to Analytics Vidya. Do 2 articles, then you will understand the process. Then you can go into research paper publications. See, ultimately, you have to produce. See, what Sai Charan did is the same thing, research. He came up with that PPT based on some research. So he has gone through the process. He identified a model, then he worked on it. He experimented with different types of images, data, and then he finally came up with that. And he is now doing even more challenging tasks. He is taking interest. He only told that I want more challenging tasks, because the more challenging he works, the more future salaries he will get. It's simple as that, right? So he is now at around 8 lakhs. I think he is now junior data scientist. He joined as intern. Internship, he kept learning. This is all he worked on during internship only. Junior data scientist. He joined as data science intern. July 22 to February 22, 8 months, he worked on that internship thing. He worked on three projects. One is that image processing, one ML project or some other project, and one time series project. Finally, he showed here. See here, the VGG net, which he has done. Now he has been junior data scientist. Happy Monkey, and his package is around 8.85. So this is how it will work. So this is my firm only. He has done that Medicare thing, no? So internship I have given from March to June. Yeah, you can. If you are interested, if you are really interested, but you have to do it proper project. Then I'll give you the certificate, internship certificate. You have to do it in proper methodology with all like how we do it in the classroom. End-to-end project has to be done with PPT. You will have PPT and all if you can create.
PPT and what you are doing at what?
Yes, you get 5 slides. 5 slides. Introduction of the business problem, then methodology for data methodology, then data pre-processing, then model building, model comparison. Only 5 slides with the data tables. In Excel, you do all the metric comparison and all, and you give it and upload the full project in GitHub. Yeah, I work on consultants this also. So actually, I am now working with BITS Pilani. 3-4 projects are real-time projects. With BITS Pilani projects, which I am guiding, out of 40 students whom I am guiding, 4 of them are purely real-time, confidential data and all. Their company managers are also the mentors and all. So they are working on real-time projects. So one is Pepsi. They are building a supply chain analytics model. So real-time projects also there. So I'll be consulting on that project. See here, the over footing is very less compared to the decision tree, right? So random forest is giving 93.65. See, all you have to do is you have to practice. That is what you have to do. Keep this notebook open. You have yellow taxi data also on the same website. Yellow taxi is 2 lakh observations. Do the same, exactly same variables. Exactly same variables are there. Yellow taxi. Only thing is 2 lakhs. This is 63,000. That is 2 lakhs. That's all. You have to do exactly same process. You can try on yellow taxi data, right? In the same website where we have downloaded the green taxi, there you have the yellow taxi data also. Try it if you have time today, or try over this weekend. Get in touch with me next week. So you will understand the process. Keep this open step by step. Do whatever is done, do it on that data. Okay. So yellow tax is also similar data. No change at all. Oh, very large data. 32 lakh 52,717. 32 lakh 52,717. So we will try it with Apache Spark. You can't do it on this one. You can do some other month's data you can take then. Some other month's data you can take. Okay. See, what exactly we have done here is, first we have identified columns. or variables. We have first identified from info. Dot info is the command. We have identified null, and then we split data into object and numeric calls for missing value. Because we have missing values, we have split the data into object calls, and then in object calls, what we have done, we have imputed with most frequent. Then in object calls, we also did something, right? Since they are very few, right? Very few were there, so we have merged the levels or classes. After this, what we did in num calls, imputed with, we have imputed with null calls with. Now, then we combine object calls and num calls, one data frame, right? Then we have done data aggregation and data visualization. As part of, we have done aggregation visualizations, the bar charts and pie diagrams we have created. Then what we did, we hypothesis testing we have done. We have done 2 t-tests, 2 ANOVA, variable and important. Okay, this is what we done yesterday. Till yesterday we have done this thing. Now, then we started looking at date, time, variables. Today what we started with was, we have started looking with date, time. Shall I add multicollinearity also here? And correlation analysis, num calls only. And identified, what we identified? Multi. Then we started today with date, time variables. We started with date, time variables. 2 variables were there, drop off. First, what we did, we calculated the time delta. Time delta means difference between 2 times. 2 date time 64 ns, right? 2 date time 64 ls. What is the one we have taken here? Drop off time. We call it as duration, right? Trip duration. Trip duration is equal to drop off time minus. Then what we did, we converted date time format to and divided by, right? This is what we did. Next, we converted the date time to seconds, dt dot seconds. Then we divided and we converted into minutes. After conversion of minutes, we have created a new variable. In num calls trip underscore. Then we also extracted hour and weekday and added them new variables dt dot hour, dt dot weekday. Hour and weekday we have extracted from drop off time, not the pickup time. Drop off time we extracted dt dot hour. I'm writing it here, dt dot hour and dt dot seconds, right? Or second. Yeah, but pickup time is not the right time. Drop off time should be the time of concern. Technically, that is what is more important, right? Pickup is also important, but drop off will make logical sense.
If you are telling traffic and also.
No, you can take pickup also. So we have extracted them into these date or time variables. Then we dummy encoded object calls. Then we combined both num calls and object calls into one. Then we split combined data frame into y, which is total underscore amount, model building and model comparison. Model building and comparison. See, model building is the thing is what we have done yesterday and today, majority of the time was cleaning variables and extracting variables. You should be able to generate information and value addition to the client. Then only he will pay you is it clear now, the process? We have not done scaling. Why? Because all the numbers are small. All the numbers are small only, right? 20, 10, 1. If there is a larger number, then thousands is there, then we could have done scaling. But here all the numbers are in small, tens only. Or it is on ones, twos. Majority of them are in tens. Then no need of scaling.
The trip type is numerical and category.
Which one?
Trip type.
1.0.
1.0. That is trip type and category value.
Yeah, that's what.
So
we have moved it onto object calls.
But we excluded while doing dummy encoding.
No, we have not excluded.
Check object.
See here, trip type 1.0, 2.0. Payment type. We have not excluded them anywhere. My access trip type, na? Here, see here. And all the payment types.
The scheme was not removed, that's right.
I have not done anything. How can I input that? That's right.
OBJ calls dummy once, please.
Yeah.
No, sir.
See, payment type, trip type are there. They are very important columns. Now, how will I miss them?
No,
That is out of question.
those two are the visible.
See, payment type, and trick type. That's what. If you follow the procedure which I am telling you step by step, you will not make a mistake. If you don't follow, if you miss something, you just tell me. I'll go back and show you that step. Please don't hesitate, because that will create more problems. This is what happens. If you don't follow the process, you will forget variables. You will overwrite the data. I have seen worse things also happening. People overwrite the data completely. The mistake means overwrite of data is removed. Data completely gets overwritten with some other data. That's completely biggest blunder, right? So you should not do it. So follow the step by process. Go one by one, step by step. You will never make a mistake. And people who follow this process, which I tell you, they will do anything in any type of handling. We can do any type of data handling. We have seen in competitions and jobathons, right? For the previous batches, people who stick to my process, they submit the files in competitions. People who don't understand the process, who don't follow that, to submit the competitions, and their placements will also be difficult. So people who follow it, the process, procedure, work on multiple projects, they get easily placed.
So in competition, the main challenge is data cleaning only, right?
Pre-processing is the biggest challenge.
Apart from that, anybody can build.
Yes, anybody can build a model. That is, see, model building is nothing, right? What is there in model building? Tell me. Dot fit, call the function, dot fit, dot score, dot predict. That's all. Only three lines of 3 cells of code. But before that, how many hours we spent on this data? Yesterday, whole 4 hours we spent. Today, most of the time we spent on what? Only cleaning, extracting, correcting the data, bringing sense to the variables. Then that is what we have to do. In real time, data will be like that only. You have to bring variables out of it, like hours, weekdays.
Based on domain knowledge and all, can we eliminate some of the variables and
Yes.
build model?
Yes.
Will that make difference? in
See, elimination, you have to give a reason to the client. You cannot simply say, I will eliminate. You have to give a reason. So, like, look at this PPT. He has done normalization. He called me before that also. Why we should do that? See, initially there is no normalization here in the initial setup. See, feature vector, test data, and cosine similarity. Cosine similarity means it's like how similar. It's like covariance only. 2 classes, augmentation 9, total sample size. He has created. These are the phases he has used for cosine values for each of the phase. Then he found out there is skewness and kurtosis. So what he has to do? Normalization has to be done. Now he has added a new step here called normalizing the values. Then he sent it to cosine similarity. Then it was there. Why he has to add this? For that he has given this region also. I told him, explain the theoretical concept of impact and skewness. Because client might not know, right? What is skewness, what is kurtosis? He might not understand what is its importance, what is do. So I told him, take the skewness and kurtosis theory, put it on a slide, explain the concept first, and then you show him the table of values. He also explained what is normalization. 0 to 1, right? No negative values. Then he explained this table. Transformations 1, 2, 3, 4, 5. And then what is the change on skewness and kurtosis. And then he come up with the values, what challenges he has faced, and then he has come up with this. So this is the format you need to. So if you are saying, I want to delete certain variables, you have to give a solid reason. Without giving any reason, you can't make that decision, and client must accept it. Same thing with new variable creation also. Why you are creating new set of variables, and what statistical process you are using for creating such new, right? So all these things will be there. So if you want to work on product and all these things, it's very interesting. Deep learning, image processing, you might initially get very, 30,000 or something like that. But once you have done gained some sort of experience, you will get good packages. That is the challenge and the risk you have to take. He literally worked for 6 months, and every time any doubt, he used to call me on 3 projects. One of these is the face augmentation. The client is for attendance system. The face recognition is for, the company was developing an application for attendance based on face recognition of the employees. So Python programmers were developing the code. He has built the model and given it to them. They will develop the final application. Any doubts in the process? Is it clear now, guys?
For every unit.
We add one more step. Identify categorical calls from num calls and move them to object calls. This also we done it, right? We have identified categorical calls from num calls and then move them to object. So follow this process. If you follow and stick to the process, if you do 2 data sets with this exact same process, you will be ready for any type of challenge, right? Any doubts?
Yes.
So one thing is you also create your own flow charts. The process chart, how you want to deal with data, you can create your own flow chart also. Just write down the steps, flow chart, how you want to go ahead. Before or after, you can do that. Some people are, one of the students used to write what all steps he needs to do on a paper, and then he used to follow the process. Because what happens is you will go, once you start go into data and you hit a problem. See, one of the thing is constantly questions will be raised. Why do you think this variable is important? Why not that variable is important? Out of 40 variables, why do you think these 10 variables are important? You have to answer the question, right? And in companies, you can't give a oral statement. You have to prove it with data. In this case, we use a hypothesis test output to say, boss, I have done an hypothesis test between dependent variable and this independent variable, and I got reject null hypothesis. If reject null hypothesis means the variable has an impact on, if it is failed reject null,
There is
no impact, not a significant variable. So out of these variables, why only you are choosing these variables means you have to answer that question. We call it as validation. We call it as validation process. So validation has to be given. You have to give it with proof. I have done this test. We are done doing two tests. So in reality, if you have more variables, you might be doing 30 hypothesis tests also. 30, if you have 100 variables, you have to do 30 hypothesis tests of different variables. Not all 30 will be reject null. Some will be failed reject null also. On that, you can come up with the variables which are important, which are not important. So for purpose of validation is what inferential testing or hypothesis testing is. You have to validate this reason why you are choosing those variables as important. Because we can't take all the variables. You have to start somewhere, right? And start reducing the variables. Then we will also study algorithms to do that. We have algorithms to do that. Dimensionality reduction. We will work on that also later stages. But before that, we will do manual feature. We already studied tree models will give us variable importance. Tree models will give us feature importance, right? That also we can choose.
Yes.
In tree models, we get the feature importance. Take for example, for these variables only, pd dot data frame x dot column, sorry, x underscore train dot columns rf model dot yes yes sort underscore index ascending the variable which you have created, very important variable. Trip duration we have created, right? That is very important variable. Similarly, rate code 2346, we combined them. Okay, it's 1% only. You can take up to tolls amount, significant variables. Our day 0, result 6. So rest of all are non-significant. They are all less than. Per amount we drop now multicollinearity. These are all zeros. 0.00 means it's 0, right? So important are variables are till this point only. Only these are our important variables. Rest of are not important. You can see tree model also. This E minus means it's less important. What you call 0.4221, our 19 tip amount, 0.3, 0.01, 111, and then these are all. Okay. So you can do a lot of things based on the data you have. You can create. Ultimately, it has to create value addition to the client. The client should see some value addition from the data analysis and the model building you are doing. Then it will be very, very, you can rework the models.
So yesterday's regarding
I didn't upload, huh?